Hello.
Yes, sir.
Here, can you able to see the slides here?
Yes, sir.
And don't mute yourself. I have unmuted yourself. If there is any problem, audibility or any video problem is there, and you can just intimate me because I don't know what is happening in the remote side.
Okay, sir.
Reading point.
Yes.
First, I will be going through the slides, and I will be showing you the packet tracer, how this routing information protocol works. Okay. What you do in the sense whether the slides have been shared, and if when I switch over to packet tracer, uh, uh, ensure that the packet tracer packet whether the packet tracer is visible or not.
Okay,
Can,
sir.
can we be okay? Hello.
Yes, sir. Yes, sir.
Okay. Good morning, one and all present here. Thanks for joining this session. So today I will be discussing about unit number 5, routing information protocol, RIP. So what is basically routing information protocol is, it is comes under the category of intra-domain routing protocol. We have seen that two different types of protocols. One is intra-domain and inter-domain protocol. Is the RIP, OSPF, they all comes under intra-domain routing protocol. That means that comes under the category of interior routing, whereas for it can be applied only for this protocol can be applied only for a particular autonomous system. Autonomous in the sense you can have your own topology like network topology, and router will be configured with this routing information protocol. So it acts only in the border of this network. So exterior is something like BGP. BGP is a border gateway protocol where you can able to switch from one network to another network. Like two WAN can be connected. So this not comes under this exterior. This protocol comes in the autonomous system. And speciality of this RIP information protocol is very simple, and it works on the basis of finding out the shortest path from source to destination. So it keeps a hop count. You know what is a hop count? It measures how many number of routers are there. So based on the hop count, you can able to find out which is the shortest distance. So it simply employs only the hop count as a routing matrix to identify the source to destination, and it prevents the routing loops. That means if the hop count exceeds a maximum of 15, in routing information protocol, the maximum of routing hop is only 15. If it exceeds the maximum of 15, this won't work. So your packet will not be in a routing loops. It will not be stuck up with the loops. So these are all the major significance of routing information protocol. And there are two versions of routing information protocol. One is version 1 and version 2. Version 1 was started in the year 1988, and it uses a classful routing. And the problem of this routing information protocol version 1 is it doesn't support for variable length subnet mask. That is, you cannot have a network, you cannot divide your network into smaller size networks. So there is no concept of variable length subnet mask. So that is one of the drawback of this. And one more drawback is that it is not much secure, because only router authentication is provided, and there is some chances of different types of attacks for these routers. So router is not secure. So there are different types of attacks is possible. So these are all the version 1 features. And the operations, when it comes to the operations, there are two types of messages getting transferred from source to destination. One is called request message, another one is called response message. So basically this routing information router, what has happened in the sense, it initially to find out the shortest path, it identifies the neighboring nodes. So what it does in the sense, the router, each and every routers will broadcast the request messages to all the intermediate devices, and all the intermediate devices will learn the information about the neighboring routers, and whichever the routers sending request, and all the routers will get updated its routing table, and this routing table will be passes over to the intermediate routers. So this what happens. So everything will broadcast, and whichever gets a response messages, and that routing table will be updated. So each and every router will have a routing table, and the routing table gets updated because it is an autonomic way of doing. It's not manual way of doing things. It is an autonomic way of uh, uh, updating the routing table. So based on the broadcast message, request and response message, this routing table gets updated. And here there are three specifications as per the following rules at work. If there are no routing entries matching, that means that if there is no route, already the routing table is at the entry of the first time. If there is no routing entries, what it happens, and whenever a request message comes with that routing entry, so what is the routing ID, what is the routing IP address, what is the IP address of that router. So these are all the what is the subnet. So these are the information will be collected, and those entries will be added to the routing for the first time. So each and every router at the starting of the time, when it receives the request from different routers, it able to update the routing. And if suppose there are entries are already there, and if there are matching entries, and it will check whether the hop count is lower. If the hop count is lower, then already it is in the routing table. So that routing table will be updated with the lower, because suppose if the packet is sending from source to destination, and if the first time it receives a hop count of 3, and the next time if it reaches the destination with a hop count of 2, what it happens in the sense, the routing table will be updated with only the hop count of 2, because already you have a hop count of 3 that can be reaches to the destination, but it is higher. So whenever you have a routing entries that coming with the hop count as less, and it will be compared with the routing already in the routing table entries, and whichever is has the least update, least route hop count, that will be updated in the routing. And the next point, last point, you can say that if the hop count is, if it receives higher than which is already in the routing table, then it won't be updated, because the previous entries are the one which has the least hop count, so that will not be updated. And whenever a packet which has from source to destination, which takes a hop count of 16, that goes at an infinite hop, so those routing tables will not be updated. So these are all some of the following rules to be followed. First time, it learns with the neighboring entries added to the routing table, and it sees to that what is the hop count of the received packet. Whichever the hop count is less than, the routing table will be updated accordingly. Otherwise, it will not be. And these are all the RIP configuring commands used for providing routing table. One is you can use IP routing, which enables a router, and you can use router RIP to get configuration commands to, like, router will have a configuration. What you can do, you can set this configuration router RIP. That means the router will have a routing information protocol. So those software can be embedded into it. And you can provide a network address which tells the router which network you want to advertise for broadcast, and all which network you want to broadcast the network. And for writing few commands, you can use write or writer. And when you want to show IP route, when you use this command show IP route, tell you use the routing table, each and every router's routing. These are all the commands to be used for RIP configuration. And these are all the limitations of RIP. The hop count cannot exceed 15. Simply routers will be, the packets will be dropped. And these RIP networks are very flat. It won't be applied for other boundaries, like exterior networks. It won't be applied. And there is no support for VLSI. So these are all some of the limitations of version 1. So version 2, this these are few enhancements that has been made for version 1. So you have a classless inter-domain routing support, CIDR, which has subnetting mask can be applied and variable length subnetting mask can be used. And there is no broadcasting here because whenever you do a broadcasting, suppose if there are 10 more neighbors are there, and suppose only 2 neighbors are very active and 8 more neighbors are not active, means based off you have to send all the packets to all the neighboring groups. So what you can do in the sense, instead of that, you can form a group which are all the participating, which are all taking more actively participating in the network. What you can do in the sense, you can configure those nodes and you can form a multicasting network. So broadcast means you can send a packet to all the nodes, whereas a multicast means you can select based on the active, you can select and appropriately the packet will be routed to the corresponding entries. And this is the multicast address to be used for version 224.0.0. And there are a few limitations of RIP v2 also. It has a authentication support, but still it is not very secure. Only a few text entries are there, password entries can be provided, but it's not fully secure. And as the packet size increases, as the number of networks increases, it cannot be suitable for larger networks, and it is more prone to link failures. So these are some of the drawbacks of RIP version. I think hello, hello.
Yes, sir.
Whether you been able to see the slides?
Yes, I can.
Once again, I am switching over to packet tracer. Just see whether the packet tracer is visible for. Okay, tell me.
Okay, sir.
Whether it is visible.
Yes, sir, it's visible.
Okay, fine. Now I'm going to explain about this with the topology, how this RIP works. So already it has been configured. I have taken this topology. So this is the PC. This host has a network of 192.168.10.0. So this PC has this network, and this these are all the routers. So how many routers I have configured is 1, 2, 3, 4, 5. So I have 5 different routers, and this is a topology I have configured. And this routers, this and this, these two routers as the network of 192.168.20.0, and this network, these two routers has connected with the network of 192.168.30.0, and these two routers are connected with the 40 network, and these two routers are connected with the 60, and these two routers are connected with 50. And destination host has the network of 70, 192.168.10.70. So how many networks? I have 7 different networks, right? Source network has 10.0, destination network has 70, 10.70. And these are all the intermediate networks, and each and every routers play a very important role in each of the networks. So you know how to configure and these and all, right? To connect this PC to this. So what I made here, you can see here the IP address of this host is configured to 192.168.10.2, right? And you can see this 10.1 is used for this connecting these routers, right? So you can see here this router has 180.168.10.1 that has been connected to one of the interfaces, and you could see here this router has 3 interfaces, one to connect with this PC and another to connect with this router, and third one, this is to connect with these routers. So these are all the things I use. So this is to connect with the 20.1. Another has been connected with the 50.1. So this is 50.1 and this is 20.1. And when you, similarly, these routers, you can see there are two interfaces, right? One is 20.2 this is 20 network, so 20.2, and this interface is 30.1. So you could see here 20.2 and 30.1. Similarly, for other routers, see there are two interfaces. One is 30.2, another one is 40.1. This one is 40.1. And similarly, this one is 40.2, and this interface is this interface is 60.2, right? This is 60.2, this is 40.2. And similarly, when you come over here, this is 50.2, this one is 50.2, and this one is 60.1. And this one is connected to this destination Vishwa, and this one is 70.2 interface. This IP address is 70.2, and this one is 70.1, right? So these are all the things I have made. Hello, hello.
Yes, sir.
Any issue, huh? No problem, right?
No, sir.
Okay, fine. So after doing this, all those things connecting with routers and all, just click these routers, and you can see here what you have to do in each and every router in this. There will be an option called RIP. Just click this RIP, and you come over here. See, for these routers, you have to add the intermediate, like the other the neighboring networks. See, for this router, we have three networks. The networks are there. One is 10.0, another one is 20.0, another one is 50.0. So these are all the things I have added. 192.168.10.0, 192.168.20.0, and 50.0. So what you have to do in this end, you have to just type, and you have to just type here. Suppose if you want to add one more network, uh, 40.0. What you can do in this end, after typing this network address, just press add. That means this network will be added, right? So you can also remove, if you want to remove this one, just select and just, right? So so just click this, go to RIP, and find out which are all the networks has neighboring networks. So 10.0, 20.0, and 50.0. You can also give as a fly command also. What you can do is you can use like here router, just type router in, and for adding you can use network. Suppose if I want to add 192.168. Suppose if you want 80, something like 80.0, just type network, that address. Now this network will be added. So you can go to configuration, go to RIP. You could find here now the new network is in added 192.168.80.0. So you can use directly GUI commands, or you can use the fly commands. You can also manually configure also. Okay. So 80.0 I don't want, just so these are the things you have to do for each and everything. So this is for first router. And for these routers, you need to have this network. One is 20.0 network and 30.0 network. So when I just click here, go to RIP, you can find here 20.0, 30.0. So similarly, what you do in the sense for each and every router, go RIP and add all the neighboring networks. I think we're running out of time. So this router has three interfaces, right? So three networks is possible. One is 40.0, 70.0, 10.70, and this one is 60.0. So after doing this, what you do in this end, you just select packet from here, and the destination is here. Then you start simulation. So just turn on. So what you can do in the sense the packet is being routed here and it comes over here. Yes. And it also comes to the destination. Yes, it reaches the destination. Again, it will come back to this path only. It comes to this router now. Again, it goes to this router. Then it finally reaches the source. Right. So you can ask me. See, it takes only this path, right? Why can't it takes this path? So this router one, router two, these routers again. See this router, this one, this one, this one, this one. That means how many number of hops? See, when it takes this path, it has 1, 2, 3. Only 3 hop count is 3. Whereas if you take this path, 1, 2, 3, 4. So total hop count when it takes this is 4, but it takes only 3 to reach this destination. So always this rip takes the shortest path from the source to destination. So you can also check with other things, right? Just here and this one, this one. So one packet and another packet. This, this one, another packet is here. Again, same distribution. So I run this command, right? Yes, this is the first packet comes over here. Second packet is also coming. The same path is also taking out the same path, taking out the same path. So when you have more than one packet, it takes a shorter. So even though this traffic is it's not busy, this traffic is also very busy, but it takes only this shortest path. So when you the only drawback of this RIP is right. Only hop count, it measures the hop count to reach the destination. So you cannot have bandwidth, you cannot have a delay, cost. Those metrics will not be added into this network. That is only the only one drawback of this RIP. Again, if there is no secure, you cannot have secure configuration. So that is the only drawback. And if suppose if I remove this link, suppose if I break this link, what will happen in this? Suppose there is a failure in this link, what will happen in this sense? So suppose if there is a failure, or it takes only this path to reach this. That means it won't connect this path. Okay, so it takes this path. This this path it will be connected. Okay, so I think only 3 more minutes are there. Somebody is raising hands. So I has raising hands. So I have dropped hands. Any doubts, Ra? Anything for RIP? This is about RIP I want to show. Hello?
Sir?
Any doubts, Ra?
No doubt, sir.
Anybody is having doubts? Next week I will only two more topics left of OSPF and EHRP. Next week we will handle. Next week is going to be the last week, I guess. So this week MCQ is Unit 4. I think I was lots of you. What's the fourth unit MCQ? Hello? Deepa?
Sir, how did you use the rip command?
Router, sir. Hello? Hello? Deep? Hello? Hello, Deep?
Yes, sir. How did you use the configuration?
Yeah, in routers, go to routers. Don't mute, hello?
Yes,
Hello?
sir.
Yeah. Go to routers. There is an option called RIP. Can you see this? Hello?
No,
It's not
sir.
opening. It's not opening.
Not opening here, but in my system, it's. What about this packet tracer is visible?
Yeah,
Yes.
packet tracer is visible.
Okay, okay, okay. Then I want to share it. Okay, 1 second. I'm opening this. It's not visible now for you. It's not visible, right?
No, sir.
When you open this, how to share?
So just take a screenshot of that and post it in the group, sir.
Okay. See, I will tell you, like when you open this, there is a option called configuration. We use like gigabit Ethernet serial IO buttons, right? Left side. The same panel, you could find RIP. Just click it. Otherwise, what I'll do in this is I'll take a photos and I'll post it. Okay. So when you click this RIP, you can find the network address to be added. Just type the network address to be added, which are all the neighboring networks. You just type the address of the neighboring networks and just put the add. That's it. This is one way you can do. Otherwise, go to CLI option. There is an option called CLI. What you do in this sense, after configuring the routers, what you do in this sense, provide a command called router rip. Router rip. After that, what you do in this sense, for adding a network into the router, just type network followed by the network address. That's it. Suppose if you want to remove the network, what you do in this sense, type no space network, give the IP address of the network IP address. So this is the way you have to configure the RIP commands in the routers. Understood, Deep? Hello? If there are any doubts, sir? Otherwise, we'll close the meeting. Millennium?
Yes, sir.
No doubts, right?
No, sir.
I think no, there is no thing. The commands are not visible there. That what I do.
Yes, sir. This thing was not visible.
But where you see whether the packet has been flowing from source to destination. No.
That thing I saw. That thing I saw.
Okay. Only that command that I will post in the group how to configure it. Okay.
Okay, sir.
Okay. Thank you. I am just end up the meeting now. Thank you. Thank you.